day. How are you? Hope that you're doing well. So in this video, we're going to be focusing on this previous question paper question, which is based on 2D trig, right? So now we're going to try and solve for the following questions together. So now we're given in the diagram below a right angle triangle, which is ADC. Now they're telling us that BDC, right angle BDC, right, is equals to A, and also AD is equals to H units. Now they also told us that the angle ADC, which is in the bigger triangle, the bigger right angle triangle, it is equals to theta. Now 3.1, try to determine the size of ADB, so basically the bigger triangle. So let me just try and draw this here. So if I were to try and draw that here, this is A, this is D, this is B. Basically they're referring to this angle right over here, right? This angle here. Determine ADB in terms of theta. Now, how would I go about doing that? So I know that looking at the bigger triangles, right? So in triangle ADC, I know that angle ADC, which is this triangle as a whole, or rather, which is this angle as a whole, this is equals to angle ADB, which is this angle here, plus angle BDC, which is this angle here, right? This makes up the whole angle ADC. Now, my ADC, I was told that, okay, it is equals to theta, and my angle ADB, which is what I'm trying to solve for. I'm just going to write it as angle ADB plus BDC. Now my BDC is equals to A. Now as a result, my angle ADB, it is equals to theta minus A, right? So let me just try and write that there. And now for the next question, determine the size of B1 in terms of A. Now they're referring to this angle here. Now naming my triangle, in triangle, you need to name your triangles. In triangle ADC, I know that if I take angle A and I add it to angle D and I add it to angle C, I should get 180. And reason being, this is sum of angles in a triangle. Now, I need to find my angle A, right? Because why? If I could find, I know this angle right over here. If I could find A, this would enable me to find B. So A, which is what I'm looking for. Now, my angle D as a whole, remember they said this, it's equals to ADC, it's equals to theta. So A plus theta plus C, which is 90, this is equals to 180. So that my angle A, it is equals to, so taking 90 to the other side is going to be negative, and 180 minus 90 is 90 minus theta. So I know that angle A is 90 minus theta. So now I'm going to do the similar thing to find my B1. So now I'm going to use triangle ADB, which is the upper triangle. So I know that if I could take my angle A plus my angle ADB plus B1, all this should be equals to 180. And reason being, this is sum of angles in a triangle. So now my angle A, which is 90 minus theta, plus my angle ADB, which I've calculated as theta minus A, and as I've said, plus B1, everything should be equals to 180. Now I'm left with simplifying. Now if I simplify here, this two are going to cancel out with one another. And now I'm going to be left with 90 minus A plus B1. This is equals to 180. Now my B1 would be equals to, taking the 90 to the other side, it's going to become a negative, and 180 minus 90 is going to be 90, and taking the A to the other side is going to be positive. So B1 basically is 90 plus A. So this is 90 plus A. Right. Now let us try and solve for 3.3. So for the second question, we need to prove that AB, it can be written as, so let me see here. So AB can be written as H sine So I have theta minus A all over cos A. This is what I'm trying to prove. Now, where is my AB? This is my line AB. Now, remember, here you need to try and choose whether are you going to be making use of the cos rule or are you going to be making use of the sine rule. How would you know which rule to use here? So let's start with the sine rule. In which scenario are you going to use the sine rule? This is if they gave you the angle opposite to the side you're trying to prove. So as you could see here, we're trying to prove that we're trying to prove for side AB, and the angle that we've calculated that it's opposite to this line, it is theta minus A. So meaning that here we can make use of the sine rule. All right. Now, if maybe let's say we didn't have this angle right over here, which is opposite to AB, this would have meant that we would need to use the cos rule. So now we're going to make use of the sine rule because why? We have the angle opposite to the line we're trying to look for, right? Over sine B. So now substituting my line AB over sine, the angle opposite to AB, it's theta minus A, and this is equals to, now I'm going to be focusing on triangle ADB, right, which is the upper triangle AD, or rather ADB, sorry, right? So this is going to be my main focus. So now, what other line do I have? I have this line from A to D, and I also have the angle opposite to it, which is B1, which is 90 plus A. So sine 90 plus A. So now substituting my AB, I don't have the value of my AB. This is what I'm trying to solve for. Sine theta minus A. This is equals to my AD, which is H, all over. Now, every time whenever you have sine 90 of something, as well as cos 90 of something, whether it's minus or plus, your identity would need to change. For example, in this instance, this identity would need to change to cos. And this below instance, this identity would need to change to sine. Now, let us try and change this sine identity of 90 plus. So if I were to draw my cast diagram here, 90 plus x, it's in the sine quadrant. So sine is positive, meaning that sine 90 plus a, it's going to change to positive cos a, right? So here I can write that as cos a. All right, now I need to simplify this and make this equation to be in terms of AB. And how can I go about doing that? So if I want to make this equation to be in terms of AB, simply I need to multiply both sides by sine theta minus A. So sine theta minus A, so that these two can cancel out one another. And this side I would be left with AB. It is equals to, so here I can multiply numerator by numerator, denominator by denominator. And if I do so, at my numerator would have H multiplied by sine theta minus A all over cos A. And this would be my final answer. All right. And that will be all for this question. Now, for this 3.4 question, they say determine the length of AB. So first, let me write down the equation of AB. So AB, remember, I proved that AB it is equals to H multiplied by sine. So let me look at that equation again. Sine theta minus A all over cos A. Now, on these type of questions, normally what they need you to do is just to substitute the values that they gave you. As you could see here, we need to substitute the values they gave us. So our value of H is 17. So even if you didn't manage to prove this here on 3.3, but then for the preceding question, you just had to take whatever that they asked you to prove, and you needed to substitute these values that you're given here. So 17 multiplied by sine, my theta is 58. This is subtracted to my value of A, which is 23 degrees, all over cos 23. And now let me punch this into my calculator. So in my numerator, I have 17 multiplied by sine 58 minus 23. Denominator is cos 23. And my AB length, it should be equals to 10,59 units. And now this question, they want us to calculate the area of triangle ABD. Now let me try and highlight the triangle here. Now remember here, they want us to calculate the area. So what is the area rule that we know? So let's say if I have a triangle like this is line A, this is B, this is my angle C. So to calculate the area, I would need to say 1 over 2, the length of A multiplied by the length of B, and all multiplied by sine of angle C, which would be the angle which should be here. All right, now here, so let me just try and draw ABD here. So I have A, this is my D, this is my B. And I remember my A, it is 90 minus theta. I have this angle as theta minus A, and this angle over here is 90 plus A. Now, I know that this is H. My AB before, I've calculated it as 10,59. So I have the length of AB, I have the length of AD, which is H, and my H, I was told here that it's 70 units, right? So I have AB, which is 10,59. I have my H, which is 70. And I have this angle right over here that they both make, which is 90 minus theta. So now I can use the area rule here, right? So I'll say, right, 1 over 2. So remember, let me indicate my alphabets here. This here is A, this here is B, right? So this line goes up until D. So, all right, I would say 1 over 2 multiplied by my line AB multiplied to AD multiplied to the sine of the angle they both make, which is sine angle A. So substituting my values 1 over 2, my AB, as I've said before, I've calculated it as 10,59. Now my AD, so right, so here is supposed to be AD, not AB. Let me just erase. My AD, which is my H70, multiplied by the sine of the angle that they both close, and this angle is 90 minus theta. Now remember, they gave me my value of theta above, and they said my theta is equals to 58. So basically here, this is the same as 90 minus 58. And 90 minus 58, it is equals to 32. And now if I punch this into my calculator, I'm going to get my area. So 1 over 2 multiplied by 10,59 multiplied by 17 multiplied by the sine of 32. This should be equals to 47,70. So if this is in terms of meters, I would have said meters squared or units squared. But this would represent the area of my triangle ABD, right? And this would be all for this question. Remember, if ever you have any questions, always feel free to reach out.